In this problem, we're going to do a goodness of fit problem. So it says, conduct the hypothesis test and provide the test statistic, critical value, and p-value, and state the conclusion. So a package of 100 candies are distributed with the following color percentages. 13% red, 19% orange, 15% yellow, 13% brown, 26% blue, and 14% green. So we need to remember that those are the expected frequencies. Now, we need to use the given sample data to test the claim that the color distribution is as claimed. So, let's first go to Stat and Edit, because we know that we're going to enter the observed frequencies in L1 and the expected frequencies in L2. So the observed frequencies have to come from the sample data. So let's open the sample data. So how many red candies were there? Well, I see that there were 15 red candies observed in my sample. So I'm going to enter 15, enter. Alright, so how many orange candies were observed in my sample? 26. So 26, enter. Alright, so let's go up. How many yellow candies were observed in my sample? 7. Now again, remember, I'm not going to enter the actual weights into the calculator. I'm just trying to figure out how many of each type of candy were observed. So how many brown ones? There were 5 of them. And how many blue ones? There were 27 of them. And how many green ones? There were 20 of those. Alright, so now let's say that we're done with that. So, how many red candies were we expecting? 13% red, so 13, 19% orange, so 19, 15% yellow, 13% brown, 26% blue, and 14% green. So now let's quit out of there. Now again, because we're doing a test for the distribution, we're going to use a goodness of fit test. So Stat, let's arrow over to Test and look for the chi-squared goodness of fit test. So we enter our observed and our expected. Now our degrees of freedom are the n-1, so we have 1, 2, 3, 4, 5, 6 categories, so that's going to be degrees of freedom 5, and let's calculate this. So our test statistic is 14 point, now to 3 decimal places, it's 686. Whoops, 686. So now let's check the answer. Alright, great job, good job. Alright, so critical value, how are we going to get that? Program x2 val. Now remember, degrees of freedom were 5. And these type of tests are always right tail. And it tells us our significance is 0.01. So let's hit enter again. 0.01 was right here while we're waiting for this to work here. And what is our test statistic going to be to 3 decimal places? 15.086. Let's check that. Nice work. Now it wants the p-value, so we can always go back to Stat and then Test and the chi-squared goodness of fit test and calculate this one more time to get the p-value to 4 decimal places, 0.0118. Check answer. Excellent. And state the conclusion. So if we compare this 0.0118 to the significance level, we're actually going to fail to reject H0 or do not reject H0. So that means that there is not evidence to warrant rejection of the claim that the color distribution is as claimed. So that's fantastic, and well, we're done with that problem, so good luck in the future.